I'm Tutor Ayodele. So today we'll be looking at differentiation of vector. Sorry, we should have started exactly 4 o'clock, but due to some unseen circumstances. So sorry for coming late. So we'll be looking at this differentiation of vector. Let me make a brief announcement before we begin. So we'll be going live every week. Take note of that. We'll be going live every week. Now, it may be next week, may be the continuation of this. This is not the only question we'll be solving in this class. We'll be solving several questions. And next week, we may go to another course, or we may still pick this same course and solve questions for probably parabola, hyperbola ellipse, or we may consider another topic entirely. Okay, so make sure to always comment. Make sure to subscribe, turn on the notification button so that anytime we go live, you'll be notified. Okay, so this says different if vector A, it is vector because there's arrow here. Okay, so if vector A is given to be this, now the question says find the A, the what, the W. Now if you look at this vector A is with respect to W. First of all, you see the presence of this I, J, and K. They don't serve as variable here. They serve as durations. Okay? So these are things that made it to show that it is a vector. You understand? So this vector is a vector of A with respect to W. W. All these ones signify that it is a vector. I, J, K shows the directions. If you remember in physics, you once taught something like this. I in the direction like this, J in direction of Y axis, and K in direction of Z axis. You taught something like this in physics, maybe in secondary schools or in other level. So this I, J, K show to us tells us that it tells us the directions. Okay, but the vector is in respect to what? W. It's in respect to W. So now let's pick this question one after the other. Let's answer them. Now we have to find the A, the W. We are differentiating this vector A with respect to W. First of all, take note. It only deals with A and W. Anywhere there's no, you are differentiating this A with W. Anywhere there's no W, it is automatically 0. For example, here has W. There's W here, but there's no W here. So this is 0. This one has W, but there's no W here. This is what? 0. Okay? So there's W here. So we differentiate. Alright. So now let's write our solution. Okay? Now, the A over the W equals to, now this is W. I'm differentiating this. You know, this will give us 0, as I've said. So whenever I differentiate this, I'll then put this I at the back. Okay? To show the duration. So 3W, let's bring out 3W. Now if I differentiate this to 3W, do you remember in differentiation that whenever you are differentiating, you will use the power to multiply it, then subtract 1 from the power. Okay? So what is the power? What is the original power here? Is 1. So if I use 1 to multiply 3, it will still give me 3. And if I subtract 1 from 1, we subtract 1 from the power before, it will give me W raised to power what? 1 minus 1 will give me 0. And W raised to power 0 will give me what? 1. So 1 times this 3 will give me what? 3. So that is, if I differentiate this, it will give me what? 3. Okay? Now, I will put this I at the back. Alright, let me erase this. So if I differentiate this, if I'm to differentiate this, 4W, what will it give us? If I differentiate 3W and give me 3, so if I differentiate 4W, it will still give me what? 4. This is. If I use the 1 to multiply, it will give me 4 times W raised to power what? You know the original power before there is 1. So if I subtract 1 from it, it will give me W raised to power 0, right? 1 minus 1 will give me 0. And W raised to power 0 will give me 1. 1 times 4 will still give me what? 4. Plus 4 what? It will be 4J. 4J. Okay? Alright. And the last one here is plus. Now, if I'm differentiating A with respect to W, I will keep this 9 constant. I will keep the constant. I will not differentiate it. You know, we have 9W raised to the power of 4. Okay? So if I use the 4 here to multiply this 9, it will give me what? 9 times 4, right? And that will be 36. Now, W, I will then subtract 1 from it. So 4 minus 1 will give me what? Will give me 3. Okay? So this will be 36W raised to the power of what? Raised to the power of 3. That is for that. Okay? Here we have 36W raised to the power of what? 3. 36W raised to the power of 3. Then, if that is our final answer. Actually, that is our final answer. So this, when W is equal to 1, means, anyway, let me put K, there's K there. Take note of that, there's K. So, wherever we see W, if we substitute it with 1, here will be, here still remain 3I, here still remain 3I plus 4J plus, now I'm substituting 1, I'm replacing W with 1. So this will be, you know, it will be 36 into bracket 1 raised to the power of 3. Okay? Because W here is 1. So 1 raised to the power of 3 will still give me 1. Okay? So 1 times 36 will give me what? 36. So here will be 36K. 36K. Okay? So that is our final answer to that. But in case they don't give you the value of W in an exam, you can leave this your final answer. But in case they give you the value of W, then you can leave it like this. And you can try to simplify it further to get it. Alright, that's the first one. So let's look at the second one. The second one says the square A over the W square. Now what does this mean? This means second derivative. You know the D here is the same thing as 1 here. So it means first derivative. But here now, we can see 2 here, which means second derivative. We will differentiate twice. Then take note that when we differentiate for the first time, when we differentiate this for the first time, this was the first time. When we differentiate it for the first time, this was our answer. That was what we got from here to here, right? When we differentiate it for the first time, this happens to be our answer. So now this time around now, we are not going to differentiate whatever we have again for the second time. We differentiate it to make it second time. You know, when we differentiate for the first time, we have this. So we still differentiate this again for the second time. So whatever we have will be the value of what? Will be the value of this. Okay? So if I'm to differentiate the A with respect to W, now first of all, we have W here. There's no W here. So it will automatically give us what? 0. Nothing. So plus, we have W here is to give me 0. There's no W. Then we have W here. Yeah, there's W. So I will multiply. I will differentiate this. I will differentiate with respect to W here. So if I'm to differentiate 36W raised to the power of 3, okay? So I will use this 36 to I will use this 3 to multiply this 36. Then subtract 1 from it. Okay? Now if I use 3 to multiply 36, let's do it here. 36 is 3. Can you see? So 3 times 6, 18. We carry 1. 3 times 9 is what? 3 times 9, 3 times 3 will give me 9, plus 1 will give me what? 10. So that will be 108. That will be 108. Okay? So this will be plus 108. So when I use this one to multiply 36, it gives me 108. Then I will subtract 1 from the power. So the power here that we are left with is what? Is 2. So it will be W raised to the power what? W raised to the power of 2. That will be W raised to the power of 2. Okay? Don't forget to put K. You know, it has K here. Don't forget to put K. Alright. So we thought that when W is equal to 1, if I substitute here to be 1, what will I have? This will be 1 raised to the power of 2. And 1 raised to the power of 2 it will still give me 1. If I use 1 to multiply 108, it will still give me 108. So our answer here is 108K. That's our answer. Alright, so let's look at the next one, which is this. So we have, now this one now, we don't need to stress ourselves much here. This two lines simply means magnitude. It simply means magnitude. Okay? So the first thing is, if you are given a question, let's assume you are not given this. First of all, you will differentiate A with respect to W. And you know that this A with respect to W, we have already done it here. You can see. And which was the first one? Okay? Happens to be the first one. Alright. So after getting that, you will then find the magnitude. Now, this, the A over the W, which is this, is given to be this. So let's find the magnitude of this to get the value of this. Let's find the magnitude of this to get the value of this. Mind you that this is also the same thing as this. Okay? Because we have already substituted the value of W here. So we have this. So if you find the magnitude of this, whatever you have will give us the answer here. So to find the magnitude, you will do it like this. The magnitude of the A over the W equals to. Now, if you have questions, you can drop it in the comments. If you have any questions, drop it in the comments. Okay? So, it should be, we find the square root of 3 squared plus 4 squared plus 36 squared. That is how to find the magnitude. The magnitude of this square plus this square plus this square. And that will be 3 squared plus 4 squared plus 36 squared. Now do me a favor. Do me a favor. Now, type this on your calculator. Drop the answer in the comments. Drop the answer in the comments. You can drop it now or you can drop it later. But drop the answer now. If you can type it now on your calculator and drop the answer in the comments. In the comments. And likewise this. Likewise this. If you have to find the magnitude of this, you know, the square A over the W square is already given to be this. So if you have to find the magnitude, that is, you are finding the magnitude of this, what will it give you? Without even solving, without even making an attempt to solve, what will be the answer? This simply means just find the square root of this. It's just like you finding the square root of 108 squared. What will be the answer? Without you solving it, what will be the answer? Just type it in the comments. Type the answer. What is the answer here? Type it in the comments. Okay? Type it in the comments. Alright. Can we look at another example? Let me pick another example here. Let's pick another example. All right. Or just give me a minute. Let me check if there is a question. Let me check if there is a question. I want to check if there's a question. You can continue writing. Let me check if there's a question online. Okay. Coming. My phone is loading. Let me erase this. Let me write another question about for us to solve. let's look at another example. Somebody has question here. Someone type 108. Okay. So that is the just type it there. Just type it there. Yeah. I need more response. Please respond. As you see these questions, please make sure to respond in the comments. That is the best way to learn. Okay. So I can see some of your answers there online. You tried. That is very good of you. Okay, let's look at another example. Let's look at another example. We have f equals to this I cos 2t I cos 2t plus j. This I, it signifies duration. Take note of that. I, j, here, they signify duration. Sorry, let me put this here. Exponential 4t plus k into bracket c raised to power of 3 minus 4 c raised to power of 2, comma. Okay. Find the f over the t, comma, the square f over the square t. The square f over the t square. Okay. And another thing we have is you have to find the magnitude of the f over the t. Magnitude of the f over the t. Can you make it right? Can you make it right? These are exam likely questions. You can see I'm not just forming questions from my head. No, I pick questions that may likely come out in your exam. You can see. So these are likely questions that most of your lecturers can just pick questions from here and set it. In fact, if you understand this, it will help you, it will guide you to tackle all questions as regards to differentiation. After dealing with this differentiation, the next one I'll be looking at after this is probably if I solve one more examples, or if time doesn't permit us, I'll just go straight to partial differentiation. There's another kind of differentiation we call partial differentiation. Okay? So let's solve this one first. Alright. Write our solution. Okay? So the first one says the f over the t. The f over the t. Now, if you remember what I told you earlier, that you only have concern on where, this is f, taking it to be this, and the other one is the t. So you see that we have t here, we have t here, because we have t here, so we differentiate. We have t here, so we differentiate everything here. We only have, and maybe this is quite different from that first one we saw. When we differentiate that first one, the a to w, there are some places that they are not, the w is not there at all. Okay, there are some places that there's no w, but here now we have t all true. So we are going to differentiate this all true. Okay, now if I'm to differentiate this with this, now that is here you need your knowledge of trigonometry. Now when you differentiate this I, forget about this I, this j, and this k. This shows duration. I've said this earlier many times. Okay. So now what we have concerning is cos 2t. Now we have cos 2t. Remember that in differentiation we said whenever you differentiate sine, it will give you what? Cos. So whenever you differentiate sine 2t, it will give you just use these two here to multiply it and copy the same thing. There are just three to get this. Just pick these two, multiply it 2 times everything that's there. So this one will automatically change to cos 2t. So whenever you are differentiating from sine to cos, take note, when you are differentiating from sine to cos, you know, when you differentiate sine, definitely to give you something cos, right? So when you differentiate from sine to cos, it's usually positive. But if you are integrating from sine to cos, it will be negative. Now, you are differentiating from sine to cos, it will be what? Positive. But if you are now differentiating from cos to sine, it will be what? Negative. Take note of that. So if I'm to differentiate this, I don't want to use the what's it called? The chain rule. I don't want to waste much time. So whenever you are differentiating, just use this tool to multiply it, and you know, when you differentiate cos, definitely it will change to sine, and this will automatically change to sine. Okay? Just use this tool to multiply it, and this will change to sine. So, but mind you that if you are differentiating from cos to sine, it will be negative. And if I differentiate it from sine to cos, it will be what? Positive. So if I'm to differentiate this, I'll just use this tool to multiply it. This will be 2. So since I use that tool to multiply it, I'm not going to write cos 2t here again. This, since I've already differentiated, it will change to what? Sine straight. It will change to sine. But mind you that I said it will be what? Negative. So you put minus here. You put minus there. So that is our answer for this part. Plus, now this part now, forget about this j, as I've said, it shows duration. So what we have concerned is e, that is exponential 4t. There's a trick, there's usually a simple way to get this. I will just use the derivative, that the differentiation of the power, to multiply it, and just use the differentiation of the power to multiply it and copy the same thing back. Like for example, if I have e raised to the power of 4t now. Now what is, if I differentiate this 4t on its own, because the t we are differentiating, you know we are differentiating with respect to t, and the t is found there. It can be found there. So if I differentiate 4t now, if I differentiate 4t, you know 4t, it will give me what? It will give me what? It will give me 4. Because the power here is 1. If I use 1 to multiply it, it will give me what? 1 times 4 will give me what? 4. And if I subtract 1 from it, it will be 1 minus 1. You know, whenever you differentiate, you use the power to multiply it and then subtract 1 from the power. Okay? So if I subtract 1 here will be 0. And 3 raised to the power of 0 will be what? It will be 1. 1 times 4, it will still give me 4. Okay? So I will just use the power. I will just use the power to multiply, which is what? 4 times what is here? And which will be 4 exponential 40. That is just the simple way to differentiate this. You don't need to waste time. You don't need to waste time. Now try this. I like in a situation whereby you two students, you think you can write this one, write it down. Don't do it now. I want to give you one exercise to perform. You can write it somewhere now and drop the answer later at the end of this class. Differentiate exponential 40 raised to the power of 2. Write it down, drop the answer at the end of this class, not now, so that it will not distract you. Do this one, drop it in the comments later, okay? Alright. Now, if I differentiate this, as our answer now will be 4 exponential 40. That is our answer. So here will give us what? 4 exponential 40. Right? Don't forget to put your J. You can put it here and you can put it here. It's still the same thing. Then put it here. And your I too. Don't forget to put it. Maybe you can put it here so that you don't get confused. You can put it here, you may be confused. Just try to put your I here. You can put it here. And try to put the I here. Okay? I. Alright. Plus. Alright, now let's differentiate this now. This is very simple to differentiate. Now the K is already out. The K shows the duration here, okay? It shows the durations. Now, we are differentiating 3 raised to the power of 3 and 4 raised to the power of 2. So if I differentiate 3 raised to the power of 3, 3 raised to the power of 3. You know, we use the power to multiply it, it will be 3 times 3 raised to the power of what? You can't write 3 raised to the power of 2 again. You will subtract 1 from it. 3 minus 1. So this will be 3 times 3 raised to the power of 3 minus 1 is what? 3 minus 1 will be what? 2. So 3 raised to the power. So it will give us 3t raised to the power of 2. That is the answer for this. So I will have plus k into bracket. So when I differentiate this, I have what? 3t raised to the power of 2. 3t raised to the power of 2 minus. Now I want to differentiate this. So this will be 4t raised to the power of 2. See, if there's any aspect you don't understand, drop it in the comments. I can create time to do another live class again to explain, to ensure that what's my purpose of explaining to you and you don't understand. So feel free to drop your questions in the comments. It could be now, it could be after the class. You can write it somewhere else and drop it later after the class. But just make sure that you understand it. Okay? Alright. So if I differentiate 4t raised to the power of 2. Now I'll use the power here, which is 2. So multiply this 4, it will be 2 times 4 times. Now, am I going to just write 4t raised to the power of 2 again? No, I will have to subtract 1 from the power. So I will have 2 times 4 will give me 8t. Now 2 minus 1, it will give me 1. And 8t raised to the power of 1, it will still give me 8t. So here we have what? 8t. You can see that this is a little bit complex than the first one we did. That is why it's not good for you to miss the beginning of the class. Okay? So now we are done with the f, the t. The f, the t, which is this. But are we given the value of w, the value of t? I think the value of t. Yes, the value of t was given in the question. Where can I write it? When where t equals to 1, where t equals to 1, okay, where t is equals to 1. So you know the way students understand things is not when the tutor solve everything. Now you will do something here. You will do something here. You can try that on your own. You can try that on your own later. You can decide to put the value of t to be 1. Replace wherever you see t with 1. What will it give you? Replace it with 1. What will it give you? You know, if you have 1 here, it will be 1 raised to the power of 2. 1 raised to the power of 2 will still give you 1. 1 times 3 will still give you what? 3. Minus 3. 3 here will be 1. 1 times 8 will still give you 8. You can just make a try. When t is equal to what? 1. What will you have here? What will you have here? But this one that is actually given, we are not asked to make use of it here and here. We are asked to make use of it by the time we want to find the magnitude. The magnitude. That is where we want to apply this. Okay? So that is for the first one, which is this. Then let's differentiate again for the second time. Let's differentiate again for the second time, which is this. Which means we are going to differentiate for the first time is this. So to get the second time, which is the second derivative, I'm going to differentiate this again. I'm going to do what? Differentiate this again. Alright, let's differentiate it again to get this. Please, in case you want to chat me, you can check check my profile. You will see my WhatsApp number there. Feel free to message me. Maybe if there's any aspect you want me to teach. Okay? Maybe if there's any aspect you really find it difficult. Feel free. My email, my Gmail is there. Feel free to send me a message. And my WhatsApp contact is also there. Feel free to message me. Okay? Alright. I don't know wherever you may be watching. Maybe if I'm from any universities in Nigeria, feel free to chat me up. Okay? Feel free. Alright. Now we are differentiating for the second time this square f over the t square. I'm now differentiating this again. I'm differentiating this again. Okay? But I don't know whether you can still see the board. I don't know. Okay? Let's differentiate. Now, this time now, I want to differentiate this. I will keep this constant. I will keep this minus 2 constant. I will have minus 2 here. Keep this on constant. Now, if I differentiate sine 2 See, I explained this earlier. If you differentiate sine to t, you know, whenever you are differentiating something like this, you know, you use this 2 to multiply it, then the sign will just change to cos. But mind you that when it's changed to cos, it will not be negative. As I've said, now whenever you are differentiating sign, you can check my video on differentiation. There's some videos I did on the differentiations. You can check them. You have a better understanding of what differentiation, all this sign, this thing. Well, I will still explain here, okay? But you can still watch my other videos on differentiation. You have chain rule, you have product rule, you have quotient rule, you have many other videos like that. You can check it on my channel. It's there, okay? Now, if you differentiate this, the simple way to do it is to say, okay, bring this 2, use it to multiply, you use this 2 to multiply it. But if you bring this 2 here to multiply it, this will change to cos 2t. The 2t will still remain. But the difference is, if I change it from sine, differentiating from sine to cos, it will not be negative. But from cos to sine, it should be negative, as I said. Now, we have minus 2 here already. So, I now want to join this with this. So, 2 times this 2 will give me what? 4. So, I will then write cos 2t. Don't forget to put your I plus. Now we are differentiating this again. We have, you know, here we have 4 is already here before. So you can write the 4. Now I'm differentiating this. Exponential 4t. I will just use the derivative of what is there, as I've explained earlier, which is 4, to multiply it, and we write this back. That is a simple way. So what is the derivative of this, the power here? It could, if it is, that was why I gave you that exercise to practice. So what if you have raised to power of 2 or 3 or 4 here? How are you going to solve it? That's what I gave you. Just make sure you do it. Okay? So the derivative of this is what? If I differentiate 4 here, it will give me 4. So 4 times this, it will still give me what? 4 times everything here, it will be 4. When you use the derivative to multiply, just copy this one, right hand at the back. Bam. So it will be 4 e raised to power of what? 4t. That's just it. So if I want to match this one with this now, 4 times 4 will give me what? 16. So it will be 16 here. Exponential 40. Well, I can put my j here and I can put it here. Anyway, let me just put it here because it has j. Alright, plus k into bracket. If I'm differentiating this now, 3t squared, you will use the power to multiply it, it will be what? If you use the power to multiply this, it will be 6t. Then if you subtract 1 from it, it will be what? 1. So 6t raised to power of 1 will give me t. So 6t will be what? 6t. Because t raised to power of 1 will still give me t. So I will have 6t. Minus 8t. If I differentiate 8t, you know the power here is 1. So if I use the 1 to multiply it, it will still give me 1 times 8 will still give me what? 8. But if I then subtract 1 from the power, again, I will have 0. So t raised to power of 0 will give me what? 1. So if you change to 1, 1 times 8 will give me what? It will give me 8. So here I will have what? 8. So I will have 8 here. Alright, so this is our second derivative. Our second derivative. Okay? Now, that's our second derivative. So the next thing to look at is this. Now you can substitute the value of t to the 1. Yeah? You can do that. So if you do that, if you put t here, let's assume you put t here, what will you have? You have 2 here. If you put t here, what will you have? T times 4. Sorry, if you put t to be 1, 1 times 4 will give you what? Raised to power 4. If you put t here, what will you have? So just make an attempt. Okay? Try that. Alright, the last one is the magnitude of the F dt. This is the F dt. What is the magnitude? You know the F dt is given to be this. So now you have to find the magnitude of this. But before that was why the value of t has been given to be I, to be 1. So you replace anywhere there's t to be 1. You replace it to be 1. This is a problem. This is a problem. Okay? Let's do that. You know, I was asking you that you can be, but now let's do that. I have the F over the T. But first of all, before I calculate the F dt, let me substitute T into it first. Let me replace T with 1. Let me do that here first. Then I can then find the magnitude. So if I replace it, I will have minus 2 here, sine 1 times 2 times 1. You know T is 1. It will give me what? 2. Sine 2. Okay. You can put your I here. Plus 4 e exponential 1 times 4 times 1. It will give me 4. Okay. Plus k into bracket t raised to the power of 2. You know our t is 1. 1 raised to the power of 2 will be 1. 1 times 3 will give me what? 3. 3 minus 8 times 1 because t is 1. So that will be what? 8. I believe you have written this. Have you written this? I want to erase it now. Because we are not calculating the magnitude of d square f over the t square. We are calculating the magnitude of the f dt. That is what the question asks us to do. Not the magnitude of this. We are calculating the magnitude of this. So after you have gotten this, you then calculate the magnitude. Alright. Okay, so here we have alright. Now we have minus 2. Now can you try to punch this in your calculator? Sine 2. Now you will need your calculator to get sine 2 and to get exponential 4 here. You will need your calculator to get the value of your sine 2 and exponential 4. Yeah. Alright, let me bring my own calculator. Okay. This is my own calculator. Alright, let's solve. Sine 2. My own calculator gave me, at least, this is minus 2 times sine 2, so it will be times 0. You must approximate, at least, you must approximate it to the nearest 4 decimal place. That's why if you check your 4-figure table, it's usually approximated to the nearest 4 decimal place. Yes, as a student, as a scientist or engineering student, or any field so far, you must approximate to the nearest 4 decimal place to avoid error. Okay? So I have what? 0.0390. If you punch it in your calculator, you have something like 0.034899. But I want to approximate it to the nearest 4 decimal place. 1, 2, 3, 4. So I want to stop here. So for me to stop here, I will look at the number after it. So the number after it, if I round it up, you know it will give me 1. Any number from 5, 6, 7, 8, 9. If you round it up, it will give me 1. So if I add the 1, it will give me 1. That was the reason why I wrote 90 here, okay? Which is perfectly correct. Alright. So you can try to put your I at the back of both of them. I plus 4 times exponential 4. Exponential 4. Exponential 4. Look for exponential on your calculator. Your exponential, now to get it, if you are using this kind of calculator, it is written in, is it yellow color here? So you need to press this shift. You need to press, I want it again. So press this shift and press this line here. You can see something like E and a box on top. So you type what is it? This E here, E that is there represents exponential. So you type 4 there. Type 4. Okay, press equals to. It give me 54.5982. Give me 54.5982. That is. Don't forget to put your J at the back. Sorry, J is it. That is exponential 4. Give me this. So always put your what? Your J. Alright. Now, 3 minus 8 will give me minus 5. Minus 5, you know, it will be minus, it's supposed to be minus 5k. So, but this minus will multiply this plus, it will automatically change to minus. So that will be minus 5k. Okay? Now, next thing is minus 2 times this. Press your calculator. 390 times minus 2. It will give us minus 0.078 I. Okay? Plus this times this. If you multiply this and this together, it will give me 4 times 54.5982. This gives us 218.3928 J. This remains minus 5. Yeah, after getting this, we can then find the magnitude. Very simple. We can then find. What are we trying to do so far? We're trying to put the value of T here so that it may be easy for us to get the magnitude. If you don't put the value of T here, if you don't replace to eliminate all this sign, all this exponential, it will be difficult for you to find the magnitude. It will be difficult for you to find the magnitude. So to find the magnitude now, the magnitude will be so what is there? Square. There are times you don't need to put minus here. You can just find this square. Why? Why is it that you don't need to put minus? If you are finding, if you say minus 2 square, and if you say 2 square, as far it is the power is as far the power is even number. What do I mean by even number? Even number are number that can be divisible by 2. We have 2 is an even number, 4 is an even number, 6 is an even number, 8 is an even number, 10 is an even number. As far the power is even number, the minus here will cancel. So you see that minus 2 square and 2 square will still give you the same answer. This will be 4 and this will also be 4. But let's assume the power is not the power is an odd number. Or the power is, yeah, if the power is an odd number, it's not the same thing. If I change this to 3, it's not the same thing. This will be negative, while this will be positive. Okay, but if it's even number, you may not need to write this minus here again, because we have, it will be square. It will be square, so we don't need to write it. Sorry, you don't need to write this here. It will be square. So here we have 0.078 square plus, what is here? 218.39228 square. You don't need to put this minus, you don't need to put minus 5 square. So 5 is square, you don't need to put it, it will still give you positive. The answer will still be positive. So you can just say plus 5 square. I believe from here you can be able to finish it. Okay? So what you do is that so what you do is try to finish it. You say this guy is to say ask you to finish it, finish it. It's good. It's good. Or should I do this one for you? I've already given you one before. Let me see what I can do. I don't wish to erase the bulb. Let me just erase here. Let me just erase this part. Sorry, let me just erase it. Okay, let me erase this. And I think here should be able to contain it. Here should be enough. Let's try. Sorry, let's try. So you can punch everything at once in your calculator. Sorry, find the square root of, let me put this in here. You can just punch everything together in your calculator, everything at once. 0.078 square plus 218.3928 square, okay, plus 5 square. But I just want to confirm from the calculator if what I typed is actually correct. So here I have it to be 218.45. Okay? If you have any questions, you can drop it in the comments. Let me check for another question. Let me check for another question. Sorry, I'm coming. Sorry. Alright, let's quickly go to another question. Let me check if there's any question online. Sorry, just a minute. I just want to check if there's any question online. Sorry, just a minute. I just want to check if there's any question online. Okay. Yeah, this person tried. He tried. Wow, that is good. But you're supposed to put Tutor said 2 sine 2 plus 4 exponential 4 plus 3 minus 8. Well, you tried. But you're supposed to put k here. 3 minus 8 will give you minus 5. So you're supposed to put k here. Wow, that's good. That's good. That is good. Oh, the data is somehow, the network is not good here. Alright, let's just solve one more question. Let's solve one more question and call it a day. Let's solve one more question and call it a day. Okay? Without wasting much time, let's just stop here. But I'll give you one to solve as your assignment. I will give you one. Just try to solve this one and drop the unsigned comments. Maybe we may be having like 2 to 3, possibly up to maybe 2 to 3. I will consider if we can go live in the evening at the same time. So we can have like at least two live class this coming week. Starting from next week, you can have like 2 live class. Okay? So you just try to solve this. If A, vector A equals to this, equals to U plus 3 I minus 2, plus this J plus 2 U raised to the power of 3 K. Find the A over the U. You can drop the answer after this class. Make sure you solve it. Okay? B. Find the magnitude of the A with respect to the U. C. The magnitude of this. You can see that this is a now this is sorry, here we have they are not the same. Here is the square A, the U square. Now you can see that this is getting more complex. Over the A over the U raised to the power of 3. You first of all find the third derivative before you find the magnitude here. That is what is going on. Yeah. So do it to solve it. Where U equals to 1. Solve this in the comments. Please, this is our first live class this year, and as I've said, we promise to be going live every week. We may touch next week. It could be this same course and chemistry. It could be this same course or continuation of this and other subjects or another one. So I don't know how it will be, but make sure to stay on it. Always check our channel every day. Make sure to check it for more updates. Okay, and share with a friend. If you have any issue or you discover anything, feel free to drop your answer in the comments. Okay, thank you very much. Thank you very much for your time. Share. Thank you.